everyone, my name is Colby Wright, and on behalf of the entire Bounce Financial Training team, we'd like to welcome you to our module today on the topic of forecasting revenue. Before we dive into the nuance and the methodology of how we're going to forecast revenue, we'd like to set the stage and discuss why this is such an important topic for all equity analysts. You'll remember from the in-class training that the value of any asset should be a function of the utility that it provides, the benefits that it offers. Well, thankfully, the assets that you're trying to value, equity, are financial assets. And financial assets only offer one type of utility, and that one type of utility is future cash flows, which is why we believe that from a theoretical level, the right way to value an asset is to take the sum of the present value of the expected future cash flows. This is precisely the logic behind the discounted cash flows model. But if you're going to value a company using the discounted cash flows model, where do those cash flows come from? Well, typically the cash flows come from pro forma financial statements. And how do we get the pro forma financial statements? Typically we use percentage of sales forecasting methodologies. But if you're going to use a percentage of sales forecasting methodology in order to create your pro forma financial statements, you have to have an accurate sales or revenue forecast. Truly, everything spins off and cascades down from an accurate revenue forecast. And so that's why it matters. Now, I wish I could tell you that forecasting revenue was an exact science. I wish I could give you a formula and all you would have to do is plug and play. Unfortunately, that's not the way it is. Forecasting revenue requires a tremendous amount of subjectivity and judgment. We're going to present 4 methods for forecasting revenue in this module. Even in the decision of which method to apply, there's going to be tremendous subjectivity. Once you get inside of each methodology, again, it's going to require judgment as you execute the models. So what are the 4 models that we're going to present to you today? The first will be top-down forecasting of revenue. The second will be bottom-up revenue forecasting. The third method will be what we call the revenue drivers approach. And the fourth method will be simple trend analysis. Before we dive into the nuance of each of the 4 methods for forecasting revenue, we want to try to give you a framework from which to view today's module. Imagine the layers of any given macroeconomy. For instance, imagine the US macroeconomy. Inside of that macroeconomy, there's going to be many industries. For instance, there could be the air transportation industry, there could be the auto manufacturing industry, and there could be the food stores industry. And inside each of those industries, you're going to see a portfolio of companies. For instance, in the auto manufacturing industry, you might see Ford Motor Company, you might see Tesla, you might see General Motors. And then underneath or inside each of those companies, you'll see a portfolio of products and services. For instance, underneath the Tesla umbrella, you'll see the Model S, the Model X, and the Model 3. If you dug a little deeper, you would find that they sell each of those models into various regions in the US. Tesla sells these 3 models into the Southeast, Florida, Georgia, Alabama, Mississippi, South Carolina. They also sell these models in the Mid-Atlantic, Virginia, Maryland, North Carolina, West Virginia, and they also sell them in the Midwest, Michigan, Ohio, Iowa, Wisconsin. So this is just a way to think about the layers in our economy. If we were going to try to forecast revenue, and remember, we're always trying to forecast firm level revenue. One way to approach this would be from the top down. In other words, you would start with a forecast of the macroeconomy. From there, you would look at the industry and make forecasts about the industry. And then hopefully you would have market share data. And from your forecast of the macroeconomy and the industry and the market share data, you could back yourself into a revenue forecast for a specific company. Alternatively, we could work from the ground up. We could say, what are these companies' products? What regions do they sell them in? And we could make forecasts for the products in the regions, and then we could aggregate all that up to get a revenue forecast for the firm. So we could either go top down or we could go bottom up. We're going to talk about both of those approaches. And like I said, we'll also talk about the revenue drivers approach and the trend analysis approach. But let's begin with top down revenue forecasting. Visually, we can think of it this way. We're going to start by forecasting the macroeconomy. That's going to cascade down to a forecast of the industry. That industry forecast will then cascade down to a market share forecast, which then will ultimately arrive at a firm level revenue forecast. It's always easiest if I just give you a demonstration. So for our demonstration, we're going to try to forecast the revenue for Carnival Cruise Lines in the year 2018. Here's the great news. We don't even have to make a macroeconomic forecast because Carnival Cruise Lines operates in an industry that is watched and prognosticated by many, many experts. So there are a lot of economists already making forecasts about this industry, so we can skip the macroeconomic stage and go straight to the industry level data because there are so many economists already making forecasts and predictions. So as we look at this data, and by the way, I've pulled this data from cruisemarketwatch.com. If you look at the first set of data, this is just market share. You can see that Carnival Cruise Lines has 48% of the passenger market and 42% of the revenue market. Carnival Cruise Lines is an umbrella with many brands. It has its flagship brand Carnival, which clearly drives most of its revenue, but its next two also contribute significantly, Princess and Costa Cruises. This is super helpful information. So we want to remember Carnival Cruise Lines has 48% of the passenger market. Next important piece of data. Economists have already made their forecasts of what global passengers are going to look like in 2017 and 2018. Let's take a look at this data. You can see in this data that in the year 2016, roughly 23 million passengers went on cruises. In the year 2018, industry economists are forecasting over 24 million passengers. We're going to be able to use both of these pieces of data, market share and the forecast for global passengers, to back ourselves into a forecast for Carnival's revenue. But we've got to do some data checks. Here's a really important data check for us. And by the way, I've pulled this data from section 7 of the 10K, which is management's discussion and analysis. If you haven't learned it by this point, you will discover that this is one of your best friends, section 7 in the 10K. What you'll notice is that Carnival Cruise Lines has been operating at above its capacity. The way that they measure capacity in the cruise industry is using something called ALBDs, available lower berth days. What you do is you take the number of cabins on a boat, multiply it by 2, simply making the assumption that 2 people can occupy a cabin. Then you multiply that by the number of days the ship is on the ocean. That gives you an estimate of the capacity of that ship in any given year. You can see that Carnival Cruise Lines has actually been operating above that capacity. That just means they've been putting more than 2 people in a single cabin. But it's important for us to understand, when you do top-down revenue forecasting, there will be implicit growth assumptions baked into your estimate. You need to make sure that the company can actually do that. You need to make sure that you're not going to be forecasting growth that will exceed their capacity. Well, thankfully, at the bottom of the screen, you can see that Carnival Cruise Lines has estimated its capacity growth over the next 3 or 4 years. Carnival Cruise Lines is expecting that they will have capacity growth of 2.9 and 2.7% in the next 2 years, respectively. You could dig deeper in section 7 and you would be able to see the boats that they're going to bring online. Also, some other key data that we need to look at. You can see that in 2016, Carnival Cruise Lines revenue was roughly $16.4 billion and they carried 11.5 million passengers. That tells us on average, Carnival Cruise Lines brings in $1,422 from each passenger that goes on its cruise. So let's put all this together and see if we can figure out a reasonable forecast for Carnival Cruise Lines revenue in 2018. Well, let's assume they maintain 48% passenger market share. We know that industry economists are forecasting 24.6 million passengers in 2018. That tells me we're anticipating passengers for Carnival Cruise Line of 11.45 million. That compares against actual passengers carried of 11.52 million in 2016. Now, do they have the capacity to do this? Our forecast suggests growth over 2 years of 2.81%. They say in their 10K that they're going to have capacity growth of 2.9 and 2.7, so they should be able to handle the growth that's baked into our model. What does that mean? Well, if we add this together, what we're saying is we believe that they will carry 11.845 million passengers. If we remember from earlier data, their average revenue per passenger is $1,422. So if we multiply that together, what we're predicting is that Carnival Cruise Lines will have total revenue of $16.84 billion in the year 2018. Now, how could we make this revenue forecast better? One thing we could do is engage in a little bit more granularity. We could seek to do more granularity when it comes to the geographic regions. If you go back to the industry data, you would see that they break it down by the Americas, Europe, and other. We could likewise try to break down our forecast into the various regions. We could also try to do a little bit more granular forecasts of the sub-brands, Carnival versus Princess versus Costa Cruises. Likewise, we could try to be a little bit more thoughtful about ticket versus onboard revenue. Specifically, do they have plans in place to try to increase the onboard revenue? And if so, maybe we want to make some adjustments based on that. Also, we could engage in a little bit more analysis about market share. Do we think they're going to stay at 48%? Do they have plans to try to penetrate more and get more market share? Do we think market share might be eroded? So that's just a way for us to enhance what we just did. Also, we could think about, do they have an ability to increase ticket prices at all? So these are all just ways to add a little bit more nuance and detail to enhance the top-down analysis that we just did. Okay, let's move on to the next method for forecasting revenue. We're going to call that method bottom up. Visually, it looks like this. Instead of going from the macroeconomy and cascading down to the firm, we're going to start at the product level and we're going to work our way up to the firm. I'm going to use Apple as our example. So we're going to try to forecast revenue for Apple in the year 2018. And we're going to begin by looking again at section 7 in their 10K. And they have some really amazing data for us there. You can see that clearly their revenue has been driven for several years now by the iPhone. They get significant contributions from the iPad and the Mac, and their services are growing, but the iPhone is still the primary revenue driver. So we're going to concentrate in this module on forecasting what we think revenue will be just from the iPhone in the year 2018. Well, let's look at some data again to try to get our minds around what an adequate or a reasonable forecast might look like. So looking at the data, in 2016, they sold 211.8 million iPhones. That was a decline. In the year 2015, they sold 231 million units. Revenue, likewise, decreased precipitously from 2015 to 2016, from 155 billion down to 136.7 billion. And we also note that the revenue per unit declined from 2015 to 2016 from $670 down to $645. But we, as informed and engaged analysts, kind of understand why this happened. Going from the iPhone 6 to the iPhone 7 represented at best an incremental upgrade. So there really wasn't anything to celebrate going from iPhone 6 to iPhone 7. CNET, however, which is an industry trade magazine, has this to say about what they expect later in the year 2017. Let's read this. This time, however, things could be different. For the 10th anniversary edition of the iPhone, we're expecting Apple to come out swinging with some real breakthrough innovations. And according to the most recent rumors, some of these hot new technologies could be making it tough for Apple to deliver the goods by September. So in September of 2017, and this is when Apple usually introduces its new iPhones, is in September. In September of 2017, they're going to introduce the 10th anniversary iPhone. Industry observers are expecting big changes, exciting new technologies. You might want to know, and you would know this as an analyst, Apple has a September fiscal year end. So what are some of these new features? Let's take a peek. One of them is that the home button will either be located on the back or integrated into the screen. That would allow for them to make it so that the entire front of the iPhone is a screen, more viewing area. They're looking at using next-gen Touch ID with possible face or iris scanning technology. It may be the case that they don't even have to use your thumb anymore to get in. It might just be a face scan to get past the lock screen. Also, wireless charging, which would be a big deal for iPhone owners. Curved edge-to-edge OLED display, which would kind of catch them up to the competitors. Dual lens camera. People have long enjoyed great quality when it comes to using the camera on the iPhone. People are anticipating that this will be a big step forward. Also, enhanced water resistance. I can tell you my wife has dropped her phone twice in water, and so we would be excited about having more water resistance. So you can see some of these features are very exciting, and people are thinking that this is going to be a big step forward. Well, let's look at some other major data points, and then we'll get into the details of making our forecast. So here's some other key points. Key point number one, the last major upgrade of the iPhone was from iPhone 5 to iPhone 6. That was from fiscal year 2014 to fiscal year 2015. Now, we know units declined in 2016, revenue declined in 2016, revenue per unit declined in 2016. But that wasn't a big upgrade. That was 6 to 7. If we go back to years 2014 to 2015, we're going to get a better picture of what unit and revenue growth looks like when you're Apple and you introduce a major upgrade. Also, notice price points. The iPhone 7 sells from anywhere between $649 and $769. Industry observers are predicting that the new 10th anniversary iPhone is going to sell somewhere between $850 and $1,000, which represents roughly a 30% price increase. Lastly, we should note, part of the overall revenue decline last year for Apple was a result of Forex adjustments that probably won't be repeated this year. So let's go try to get our minds around some data. What did it look like when they went from iPhone 5 to 6, the last major upgrade? Well, I want you to notice two lines here in the data, and again, this is pulled from section 7 in the 10K. First line, notice that revenue from 2014 to 2015 increased 52% during the last major upgrade. Units increased by 37%. So the bottom line is, it makes a big difference for Apple when they introduce a new phone, whether or not it's a big upgrade or an incremental upgrade. We think 2018 is going to look more like 2015 than it will 2016. Okay, so now let's actually start working through the nuts and bolts of making our actual forecast of units, price per unit, and total revenue for Apple that's attributable to the iPhone. So we know that the growth in units over the last 2 years was very different. Unit growth actually decreased by 8% 2015 to 2016, but it increased by 37% 2014 to 2015. So I'm going to say that my low forecast for 2018 will be the average of those two numbers. So I'm averaging -8 and +37, and that's going to be my low estimate for 2018 because it's a big upgrade, 10th anniversary phone. I'm going to set my cap at 37%. That's the actual unit growth they experienced in 2015. So my range is going to be somewhere from 12 to 37. When it comes to price per unit, again, I'm going to set my low mark at the average over the last 2 years. So last year, price per unit decreased by 4%. The year before that, it increased at 11%. I'm going to take the average and call that my low mark. For the cap, I'm going to rely on CNET. CNET is forecasting a 30% growth in the price on iPhone, so I'm going to let that be my high mark, my cap. Okay, now what I've done is I've created a table. So let's go look at this table. You can see the top row in the table simply shows you 2016. So the top row in the table shows you that they sold 211.8 million units at $645 a unit for revenue of $136.7 billion. Second line says, well, what if I just use the data based on the last major upgrade? So that would be 37% unit growth and 11% price growth. You can see that gets me to revenue attributable to the iPhone of $207.8 billion. Next line, what if I use my low estimates for growth in units and price as explained just a minute ago? When I do that, so 12% unit growth and 3.5% price growth, I get a revenue forecast of $158.4 billion. Next line, let me see what the high mark might look like, the cap. Now I'm using my 37% growth in units based on the last major upgrade, and I'm using 30% price increase based on the CNET article. That gets me to revenue forecast of $243.4 billion. So what am I actually going to do? I've got to choose something. Am I going to choose the second row, third row, fourth row? I'm going to go midpoint. So I'm going to take the midpoint of growth in units. So I'm going to go between 12 and 37%, and I'm going to use 24.5. I'm going to take the midpoint on price increases as well. So I'm going to hit the midpoint between 3.5 and in between 30%, which is 16.75. When I use those two growth rates, the midpoints, I get a revenue forecast of $198.7 billion. And that's the revenue forecast I'm actually going to rely on. Now, What would be the next steps once we've done that? Now I've got my revenue forecast for the iPhone. I would need to replicate that methodology for the iPad, the iMac, services, and others. We would obviously have to change it and tweak it slightly, but it would be a similar idea. Now, what enhancements could we make to the methodology that I've just outlined? One thing we could do is we could incorporate greater consideration of regional heterogeneity when it comes to iPhone unit growth forecasts. What do I mean by that? China, if you go back and look at Section 7, Management's Discussion Analysis, China is a really, really significant driver of iPhone sales, and there's tremendous volatility. So one thing we could do is not just try to forecast total unit sales, we could try to forecast unit sales by region. Another thing we could do is we could try to get more information about what exactly are the features that are going to be in this new iPhone and what is market sentiment. How revved up are they about this? And from that, we could make a more granular forecast of exactly where we think the units are going. As an example, if you go and read, people are not excited about the home button being on the back of the iPhone. People are giving that very, very low marks. I wouldn't be surprised if Apple is scrambling to change that. So it's not just what are the new features, it's how eager is the market to actually see these new features. And we would allow that to sort of drive our unit growth forecast. Let's move forward to our third method of forecasting revenue, which is what we're calling the revenue drivers approach. Visually, this is how we think about the revenue drivers approach. You have a firm and its revenue is somehow influenced or driven by 2 or 3 or 4 external factors. And the idea is if you can pin down precisely what those external factors are, and if you can define what the relation is between the external factors and the company's revenue, then all you have to do is forecast those external factors, and then you back into your revenue forecast for the firm. The example I want to use here is ExxonMobil. So we're going to try to forecast revenue for ExxonMobil in the year 2018. Let's try to visualize, conceptualize what might be the external factors driving the revenue for ExxonMobil. So we can see here that it could be global oil consumption, it could be global oil production, it could be oil prices, and frankly, it could be 2 or 3 other variables, but I'm trying to keep it a little bit simple for us. So maybe this is the model that we think we want to pursue when it comes to trying to forecast ExxonMobil's revenue. Turns out we're not actually going to use levels, we're going to use deltas or percent changes. Now you may be wondering, why does it matter whether we use levels? Meaning, are we going to use the fact that oil prices are at $50 a barrel? Or are we going to use the percentage change from last year in the price of oil? We're always going to use percentage changes. The reason is you get stabler statistics. In other words, you can make better inferences from stabler data when you use the deltas. So that's why we're using deltas. It will always be deltas. Also, some of you might say, you know what, I don't know if I agree with this idea that consumption, production, and prices drive the revenue at ExxonMobil. Isn't it more accurate to say that global oil production and consumption determines price, which then drives revenue at ExxonMobil? That's perfectly fine. It turns out that's an empirical question, so let's investigate that a little bit. What I've done here, as you look at the screen, is I've gone and collected annual data going back to 1991 for ExxonMobil revenue, global oil consumption, global oil production, and oil prices. Then in the next 4 columns, I've calculated the percentage deltas. We're going to concentrate on those 4 columns. What's been the annual percentage change in revenue, consumption, production, and prices? The next thing I've done is I've calculated the pairwise correlations. For those of you who are statistics junkies, these are the Pearson correlation coefficients for each of the variable pairs. So for instance, if you look in the bottom left-hand corner, you can see that the correlation between the change in ExxonMobil revenue and the change in the price of oil is 80%. That's very high. We know that the Pearson correlation coefficient is bounded by -1 and 1. If 2 variables are perfectly correlated, you'll have a correlation coefficient of 1. So 0.8 is very high. Notice, however, as you keep moving along that bottom row, that the change in the price of oil is only correlated with the change in consumption and the change in production at 0.26 and 0.18. Those really aren't that high. If we honestly thought that consumption and production drove oil prices, if we thought that was a clear correlation, we would have expected the correlations to be a little bit higher right there. So we're actually going to move forward with the original model that I proposed as opposed to the model where consumption and production drives prices, which drives ExxonMobil revenue. So we're going to try out this specification. Now, what do I mean when I say specification? What I mean by that is we're going to estimate a regression. Remember, regression is a statistical technique that seeks to understand the linear relation between multiple variables. Specifically, you have a dependent variable on the left-hand side of the equation. You hypothesize that there are one or more independent variables on the right-hand side that actually determine that dependent or left-hand side variable. So in our regression specification, the change, the delta in ExxonMobil's revenue is going to be a function of the change in consumption, production, and oil prices. What we can do is we can put this data into Excel, estimate a regression, and Excel will actually give us both an intercept and these three betas, these three slope coefficients. When I estimate that regression in Excel, this is the output. Now, for those of you who don't have a lot of experience looking at regression outputs in Excel, I've lined up the regression coefficients for you. So the regression coefficient for consumption is -1, the regression coefficient estimate for production is 2.48, and the regression coefficient estimate for the change in price is 0.54. However, only one of these coefficients is actually statistically significant. You might remember from your statistics training that p-values indicate what we call statistical significance. The lower the p-value, the higher the statistical significance. There's only one variable with a p-value lower than 0.1, and that is the change in price. So we're actually going to change our model. We're going to now assume that only the change in the price of oil is what really drives the change in ExxonMobil's revenue. This makes it nice. It's very concise, very parsimonious, and we can actually visualize this. So now I'm going to create a scatter plot. And I'm going to just put on the scatter plot exactly what we hypothesize. On the y-axis, the dependent variable is going to be the delta in ExxonMobil's revenue. On the x-axis, the driver, the independent variable, is going to be the change in oil prices. And we'll be able to see a visual relationship here. So you can see that there's a clear positive relation. The bigger the increase in oil prices, the bigger the increase in ExxonMobil's revenue. I've also fitted a regression line through here, so I've basically re-estimated a single variable regression, and you can see that regression equation in the upper right-hand corner. Specifically, the intercept is 0.011, and the slope coefficient is 0.5556. Now, again, for those of you who are statistics junkies, you can see that the R squared from this univariate regression is 0.6335. That's incredibly high for a single variable regression. That's good news for us. That means we're on the right path here. So how do we apply these results? Well, our original regression specification after we did some digging is that the change in ExxonMobil revenue is simply a function of the change in oil prices. We estimated the regression and we got coefficient estimates. Specifically, the intercept is 0.011 and the slope coefficient is 0.5556. So, if we assume that in the year 2018, oil prices are going to increase by 5%, we would simply put that into the equation. And that would arrive at an estimate of growth for ExxonMobil's revenue of 3.879%. But we don't know if oil is going to increase by 5%. So let's see if we can figure out how much we think oil will increase by the time we get to 2018. So I'm going to use futures prices from the Chicago Mercantile Exchange to try to anticipate what the growth in oil is going to be. Right now, as of the recording of this video, oil is at $50.26 a barrel. If you go and look at the June 2018 futures contract, you'll see that the futures price is $52.12. Now, just accepting that the futures price is our best guess of what the spot price will be in June of 2018, that represents growth of 3.7%. So we think that oil is going to increase at a rate of about 3.7%. Well, putting that back into our regression equation, we can see that, again, our specification is we think the change in ExxonMobil's revenue should be 0.011 plus 0.5556 times our estimate of growth in the price of oil, which is 3.7%. Putting that in the equation, our estimate for the growth in ExxonMobil's revenue in 2018 is 3.157%. So we would just take the 2017 revenue and grow it by 3.157%, and that would be our revenue forecast for 2018. Now, how could we make this better? What are the possible enhancements? Well, the first thing we could do is we could consider other explanatory variables. All we considered was consumption, production, and changes in oil prices. There could be other variables that matter. We could use a more sophisticated econometric model. All I used is what's called ordinary least squares regression. Might sound sophisticated, it's actually the least sophisticated of almost all of the econometric techniques we could use. We could also try to use more information to forecast what we think the delta in oil prices will be in 2018. All I did is went and looked at futures prices. It's a pretty good proxy, but maybe there's some other data out there that we could rely on. All right, now let's talk about our fourth and final approach for forecasting revenue. This is basically the default. If top-down's not gonna work, bottom-up's not gonna work, revenue drivers approach isn't gonna work, then you're gonna fall back to probably trend analysis. Let me just show you something. Graphically, this is the actual revenue of ExxonMobil going back several years. This would not be a good candidate for trend analysis. You can see visually, using what my friend likes to call ocular analysis, you can see a lot of volatility in ExxonMobil revenues. That's going to make it really hard to actually apply trend analysis and to have any faith in your outcome or your output from your trend analysis. However, let me show you Hershey's. Can everybody see that Hershey's revenue is much smoother? And we could probably have considerable more confidence forecasting Hershey's revenue by using simple trend analysis techniques. So, okay, you can see by comparing Hershey's versus ExxonMobil that one of these is a good candidate for trend analysis and one of these is not. So as our example of trend analysis, let's try to forecast Tootsie Roll revenue for 2018. Now, here is Tootsie Roll revenue going back many, many years. And you can see it's fairly smooth. They've had a little bit of dip and they've had some ups. Recently, they've been very, very flat. Now what I'm showing you in this graph is year over year, what has been the percentage either increase or decrease in their revenue. Here, I'm going to try to make this very clear for us. If you look at revenue over the last 7 years, the high point was in 2012. It was $549.8 million. If you look at the low point, it was 2016, which was $521 million. Their highest growth was 4.43% in 2010. The lowest growth was a decline of 3.5% in 2016. Look, that represents the range. No matter what I do when I forecast their revenue, I'm probably not going to forecast growth above 4 or below 3.5. Also, we should notice sales or revenue in 2016 was adversely affected by currency translation and the timing of sales between Q4 2016 and Q1 2017. They don't think those problems are going to be repeated if you dig into the 10K and read about it. So what's the bottom line here? Sales are not likely to decline the way they did in 2016. Most likely revenue growth will be somewhere between flat and a high of 4%. So what's a reasonable growth forecast for Tootsie Roll? Maybe right in the middle of that 0 and that 4.43%. So maybe we go with 2.215%. So how would we get 2018 revenue? We would just take 2017 revenue and we would grow it by 2.215%. Now look, I know that's a very, very simple method. I've tried to show you more sophisticated methods when we did top down, bottom up, and revenue drivers approach. Again, trend analysis is kind of the default. If nothing else works, you're going to fall back to trend analysis. Now, how could you make a trend analysis revenue forecast better? Well, you could certainly use more sophistication in identification of the past trends. You could absolutely call upon sophisticated, what we call time series models, auto regression. For instance, you could use ARMAs, ARs, MAs. That's very, very sophisticated. When you start getting into that world, you have to be careful. But you could do it. You could use more sophisticated models as opposed to just looking at what the growth has been over the last 7 years. Also, you could use more info to try to identify exactly what the trend is going to be in 2018. When you dig into 10Ks, they're going to try to give you guidance. They're going to try to say, for instance, oh, last year was anomalous. That doesn't represent exactly what growth is going to look like moving forward. So you could try to use more qualitative data to influence and inform what your actual trend forecast is going to be. Okay, So we've talked about all 4 of the methods by this point: top down, bottom up, revenue drivers, and trend analysis. And I just want to remind you, this is critical. This is how you prove your worth as an analyst. If you get the revenue forecast right, the rest of it is usually mechanical. If you miss on the revenue forecast, it doesn't matter how good your mechanics are, your valuation's going to be off, and your buy, hold, sell recommendation's probably going to be off. This is where judgment comes in. This is where expertise comes in. This is where digging through the 10Ks, picking the right method, executing the method appropriately, this is how you set yourself apart as an all-star analyst. We want to give you a chance to practice. I'm not going to have you do all 4 of the methods, but here's what I'd like you to do for practice. I would like you to outline how you would forecast revenue for the next year for Seagate Technologies. The ticker symbol is STX. I'd like you to go to their 10K, learn a little bit about the company, what are their products, what have the trends been, and then I want you to just outline what method would I use, what data would I gather, how would I execute the method, but I don't want you to go through the hassle of actually pulling all the data and executing the method. This is a thought exercise. So I want you to write down what method would I use, how would I execute it, what data would I get. Hit the pause button, take some time to do that, and then come back and I'll show you how I think you could do it. All right, we're back. Let me show you how I think you could approach this challenge of trying to forecast revenue for Seagate Technologies. First off, let's look at a little bit of data. Again, I'm back into section 7, management's discussion and analysis. Actually, this is section 6, selected financial data. So this just shows you revenue. And I want you to notice that for Seagate Technologies, their revenue was flat from 2014 to 2015 and then a sharp decline from 2015 to 2016. Well, we need to understand what exactly they do. What do they sell? So if you go back in and you understand their business, so I'm pulling things from the 10K now. This is a direct quote from the 10K. We offer a broad range of storage solutions for the enterprise, data center, client compute, and client non-compute applications. We list our main current product offerings below. And you can see that what they do is they basically make hard drives. They make hard drives for enterprise solutions, so think of servers. They make hard drives for personal computers, and they make hard drives for things that people use that aren't computers, such as videos, surveillance, and other solutions for customers. So they make hard drives for servers, personal computers, and other applications. That's what they do. Let's go back into section 7, management's discussion and analysis. Let's see if we can, let's use a fine-tooth comb to try to understand how each of these divisions, how each of these products contribute to the revenue for Seagate Technology. Looking at the data, you'll see, and I want to focus on units. You'll notice that the units under the enterprise umbrella have been relatively stable. However, the units under client compute have been declining sharply. And it looks like the units under non-client compute have been pretty stable. So here's what's clear. All of the delta, all of the change in revenue for Seagate Technologies is happening in the client compute area. So if we want to really try to get our minds around forecasting revenue for Seagate Technologies, we have to figure out how to forecast units that they're going to sell in the client compute space. All right, what methodology are we going to use? Hope it's becoming obvious. We're going to use a bottom-up approach. We can see the products. We know exactly which product is the one we have to be worried about. So we're going to focus on that product and then we'll aggregate up from there. Here's some data I've gathered about PC shipments because what I'm assuming is client compute hard drives are in PCs, either desktops or laptops. So whatever's going to happen to Seagate's client compute hard drive shipments is going to be a function of what happens to PC shipments. If you look at this data, it's a little bit hard to interpret because it's quarterly. I've aggregated it annually. I'll show you that in just a second, but let's just make an observation. As an analyst, we should already understand there's a lot of seasonality to PC shipments, right? Fourth quarters are always going to be high PC shipments because of the holidays. Let me show you the annual aggregated data for PC shipments. What you can see here is we peaked in 2011 and then we started a slow decline. And we know this as analysts. We know that PCs are being used less and less as people move to handheld devices and as we access the cloud. Let me show you the year-over-year decline in PC sales. You can see in 2012 it declined by 4, then 10, then 1, then 8, then 6. What observations can we make here? Well, shipments have declined between 1 and 10%, PC shipments, since 2012. And over the last 2 years, the average rate of decline has been 7%. How does this compare to Seagate Technology's rate of decline in their client compute hard drive business? Well, in 2013, their rate of decline was 3.2. In 2014, it was 4.6. In 2015, it was 8.3. And then in 2016, it was a massive 29.5. Well, how does that line up? You can see that the decline in Seagate's client compute hard drive business is equal to or above the market most years. So what assumptions am I going to make? I'm going to assume that 2016 was a little bit anomalous. The rate of decline in Seagate's client compute business was far beyond the market decline in PC shipments. I'm going to assume that the decline in PC shipments next year will be the average of the last 2 years, 7%. I'm also going to assume that Seagate's client compute decline will be at or above the market decline for PC shipments. So what does that mean? That means my forecasted rate of decline for client compute business for Seagate will be between 7 and 29%. 7% is what I'm forecasting as the decline for computers for next year, PCs. 29% is the highest rate of decline we've seen in Seagate's client compute business. You know what? Last year was anomalous. When I look at most years, Seagate's rate of decline is right at or slightly above the market. So I'm going to judgmentally put their rate of decline for their client compute business at 10% for the next year. As we look at this then, you can see, and I have actual data, and then I'm also showing you forecasted data. You can see that this has been their rate of decline over the last 5 or 6 years, and you can see my forecasted rate of decline of 10%. How would the rest of this process play out? Well, we would perform a similar analysis for their other 2 divisions, which is their enterprise and their client non-compute. Then we would need to determine the average sales price per unit, and we would multiply our forecast of unit shipments times the average sales price per unit. I've gone ahead and done this. You can see I've created a table that includes actual data going back to 2012. Notice a couple things. Enterprise shipments has been very stable. Client non-compute has been fairly stable. So I'm actually just going to keep those forecasts stable. Whatever last year was, I'm going to roll that forward for enterprise and client non-compute. But you can see I got my client compute based on the analysis we did earlier revolving around my forecast of PC shipments. Turns out that their average sales price per unit has also been constant at 61. So I'm going to keep that constant. Then all I'm going to do is multiply my total unit forecast of 160 million units times my average selling price to get my total revenue forecast for the entire enterprise, which you can see there at 9.742. Well, I hope that's helpful. I hope you had a chance to think through this yourself, and I hope the way I did it makes sense to you. Just as a reminder, we've given you 4 methods: top-down, bottom-up, revenue drivers, and trend analysis. Wish you the best of luck, and I want to reiterate, this is really how an analyst sets herself or himself apart, by picking the right method and executing the method appropriately. Thank you and good luck.